To the video lecture for section 2.1. This is for STA 2023, and my name is Jorge Gavillan. So in section 2.1, we're going to be talking about frequency distribution for organizing and summarizing data. And so there's going to be two parts to 2.1. I'm going to go through the PowerPoint, and then I'm also going to include a video of working through some of these things in Excel. So when working with large data sets, a frequency distribution or a frequency table is often helpful in organizing and summarizing the data. So a frequency distribution helps us to understand the nature of the distribution of a data set. And so this is the beginning of what they call exploratory data analysis or EDA. So a frequency distribution or a table simply shows data that are partitioned among several categories or classes. I usually call them classes by listing the categories or the classes along with the frequency of the data values in each of them. So you have your raw data and we have to organize it in some way so it can make sense to us. So one of the first things that we're going to do some definitions. We have lower class limits. This is the smallest numbers that can belong to each of the different classes. Upper class limits. This is the largest numbers that can belong to each of the different classes. Class boundaries. Numbers used to separate the classes but without gaps. So in the class limits, we have gaps, and you'll see that when I go to Excel and also when I go through this PowerPoint. When we have the class boundaries, we don't have any gaps, and we always want it without any gaps. So we have the class midpoints. This is simply the values in the middle of the classes. So each class midpoint can be found simply by adding the lower class limit to the upper class limit and dividing by 2. You can also use the class boundaries. You'll get the same value. Class width is simply the difference between the two classes, between the two consecutive lower class limits or upper class limits. It's really how wide each class is. So what are the procedures for constructing a frequency distribution? So we usually select a number of classes between 5 and 20. I normally just start with 5 and then go from there. And then we calculate the class width. Now, so the class width is calculated by taking the maximum data value and subtracting the minimum data value from there, and then subtracting by the number of classes. Now, we round this up to a convenient number, and I usually round up to the next whole number. I know in this slide, you'll notice that they do it slightly different, and I have my reasons for that. So then we choose a value for the first lower class limit. What I normally do is I just use the minimum value for the data set. Sometimes it is convenient to use one that's slightly below the minimum, but normally you want to start with the minimum value. And then using the first lower class limit and the class width, you create the other class limits. So you take the let's say the minimum value, you're going to add to that the width that you found, and that's how you create your lower class limits. Then you're going to list the lower class limits in a vertical column, and then you're going to determine the upper class limits. And then you're going to take each individual data value and put a tally mark in the appropriate class, and then you're going to add them up to get the frequency. This is if we were doing this by hand, this is how you would do it. The process is very similar, but you don't have to count by hand. So here's the example. This is McDonald's lunch service times in the first table. So we're going to follow the procedure shown on the next slide to construct the frequency distribution shown in the second table. We're going to go ahead and use 5 classes. So the raw data is the first table. So if you notice, we have 50 data points. And so ultimately what we did with those 50 data points, that raw data, is that we created our frequency distribution or our frequency table. And you can see here in the second table there. And that's what we're going to learn how to do in this section. So again, we're going to select 5 of the number of classes. That's like the default setting, if you will. We're going to calculate the class width as shown below. Now, in this example, they had 45, so they took the max minus the min and divided by 5. They got 45. I would just round up to 46. There's really no need to go up to 50. And then the minimum data value is 83. And it says here that it's not a convenient starting point, but honestly, I don't see why not. So I'm going to follow what they say here, and then I'm going to do it slightly different when I do it in Excel. So 83 is the minimum data value. The PowerPoint, the textbook, used 75, so we're going to go ahead and go with 75. The class width that they got was 50, which is what they had when they simply rounded up to 50 to 45. So if you add 50 to 75, you get 125, and then you keep adding that 50 to each subsequent value. So then you end up with 75, 125, 175, 225, and then 275. And these are your lower class limits. So we're going to list the lower class limits vertically as shown, and then what we're going to do is we're going to create our upper class limits. And if you notice, what happens here is we simply subtracted 1 from each of the classes. Now, what they failed to do to tell you here is that they added 50 here to get to the next one, right? The 324 or the 325, if you will. So my first class is going to be from 75 to 124. My second class is going to be from 125 to 174, and so on and so on. And this is what we have here. So if I have 5 classes, I have to find 6 values. If I have 10 classes, I have to find 11 values. So always remember that. And then, of course, they counted each of the data points and they put them here in this table. And again, I'm going to show you how to do this using technology. Now, the next thing is relative frequency distribution. So a relative frequency distribution or percentage frequency distribution. So each class frequency is replaced by a relative frequency or proportion or percentage. So how do we find the relative frequency for a class? We simply take the frequency for the class or the raw number of data values or data points, and then we divide it by how many total we have. Now, to find a percentage for the class, we simply take that, what we did previously, and we just multiply it by 100. So the sum of the percentages in a relative frequency distribution must be very close to 100. Unless you round, it should be 100, especially if you use technology. So the next thing we're going to talk about is cumulative frequency distribution. So the cumulative frequency distribution is simply the frequency for each class, and it's just the sum of the frequencies for the class in all the previous classes. So when we do the frequency distribution for this particular example, we're looking for all of the data values that are less than 125. And then we got the data values that are less than 175, 225, 275, and 325. And so what happens is that we actually add these up. So this should be 50, and so there's a mistake in this thing. And I'll show you when I do it in Excel, and I do apologize. So what happens is less than 125, you get 11. Less than 175, you take all the ones that are in this class plus the ones that are in this class. So when you get to the last one, you should get the total number of data points that you have. And that's a cumulative frequency, which this is not. And so the next thing is critical thinking, using frequency distribution to understand data. So in statistics, we're often interested in determining whether data have a normal distribution. So if the frequencies start low and then increase to 1 or 2 high frequencies and then decrease to a low frequency, that can tell you that it might be a normal distribution. We're looking for a bell shape type. So this distribution, if it does look like that, it means that it's approximately symmetric. Now, frequencies preceding the maximum frequency should be roughly a mirror image of those that follow the maximum frequency. So a bell shape, if you think about it, if I split it in half, they should be mirror images. Now, gaps. The presence of gaps can show that the data from 2 or more different populations. Now, however, the converse is not true because data from different populations do not necessarily result in gaps. So, example, exploring data, what does a gap tell us? So the table shown here is a frequency distribution of the weights in gram of randomly selected pennies. And so this is a famous example that's used a lot in statistics. So the examination of frequencies reveal a large gap between the light pennies and the heaviest pennies. So this suggests that we have 2 different populations. Now, pennies made before 1983 are 95% copper and 5% zinc. Pennies made after 1983 are 2.5% copper and 97.5% zinc. Now, comparisons. Combining 2 or more relative frequency distribution in one table makes comparison of data much easier. So here, the table shows the relative frequency distribution for drive-through lunchtime services for McDonald's and Dunkin' Donuts. So you can see the time and the difference between them. So here we can compare two different fast food places to see. And so because of the dramatic differences in the menus, we might expect services to be different. Now, by comparing the relative frequency, we see that there are major differences. Dunkin' Donuts service appears to be lower than those of McDonald's, so they appear to be faster. And of course, again, that's due to the menus, right? And that's the end of section 2.1. Thank you.